So this is part of a series. There should be an annotation on the screen to the full playlist, putting out a new video every week. And if you watched last week's video, hopefully you did. We worked with mounting ISO files, and I gave 3 examples then, but I've downloaded another one just to show you as we get into here a little bit more. I downloaded a Linux Mint ISO, Cinnamon. I think it was version 15 or so that I downloaded. And today we're going to look at a little more on the bootloader and how things start up when you start booting a Linux operating system, and in this case ISOs. So we're going to start off with the tiny core, the core current ISO, because it's the simplest looking to start off with. So we will mount that to the ISO using sudo mount -o loop. Once again, depending on your system, that you may or may not need that. It may auto detect that it's a loop back mount. And again, it should be a read-only, because an ISO is basically, as far as the system's concerned, that's a CD and it's not writable. So that's normal, that warning there. We'll go into that folder, and again, with the tiny core, there's in the root directory of the ISO, there's only one directory in there, one folder. There's no files. So we'll go into that boot, and we'll list out what's in there. And there's 2 files and a folder. And what these are, ISO Linux is part of the SysLinux suite. ISO Linux is your bootloader in this case, and common for CDs. Once you install Linux to your hard drive, you have different bootloaders, but most common right now is probably Grub. And then there's also Lilo or something like that. But Grub is the most common. Well, for CDs, you're going to find ISO Linux to be the most common. And we'll go into that folder in a second. But what are these 2 other files? Well, this right here, and these names can change from distribution to distribution, but there are some common used names that they are. But this is your actual Linux kernel. If you're unsure, again, you can use the file command and give it the file name and hit enter, and it will tell you right here that this is an x86 boot sector. So it's the Linux kernel, you know from that. There's other ways you can look at that file that we'll get into future tutorials, but the file command is very helpful. You'll look here, this one, this core.gz. You're like, oh, it's a gzip file. Well, it's actually more than that. And again, the extension is mainly for the end user. The computer doesn't really care too much about extensions. And if we were to file that file the core.gz, it'll give us a little more information. You can see here that, yes, it is a gzip compressed data file. Well, what was it compressed? What's inside it? Well, it's actually, it was a file called core.cpio, which is just another type of archiving. It's an image. So basically, they created an image, and then they used gzip to compress it down to make it smaller, which is common. Gzip is not the only option when it comes to compressing the file systems. There's actually a few different ones, but when you are creating an image for booting, depending on what you have compiled into the kernel. The kernel gzip is fairly common, but there's other compressions that if you don't compile that into the kernel, it won't be able to extract this core.gz, which more commonly will be labeled Initrd. That's INITRD, which stands for Initial RAM Disk, which we will get into in here in a second. Let's go into the ISO Linux folder, and we list in here, we can see a few different files. And the main one, the first one we're interested in, is the ISO linux.config. So we will less that so we can look at it, and you can see plain text. And if you've ever messed with a grub file, it's somewhat similar, but you can see here it's the first thing it's doing when the bootloader loads, because ISO Linux is your bootloader in this case. It's displaying the contents of this file, which we'll look at in a moment. And then it's saying the default is microcore, which you can see there's two labels here. These are different boot options. The default is microcore, which is this first one here. The default does not have to be the first one on the list. That's why you can indicate it here. It could be the fifth one on the list. But whatever you indicate here will be the default, and it will default to that after a certain timeout. So you can set a timeout here, and after a certain amount of time, it will default to whatever the timeout or the default is. Before we start looking at our labels here, let's quickly look down at the bottom here. You have F1, F2, F3, F4, and then you have these other options here. And you see F2, F2. Those are actually other files in the current directory. And those are just other messages that when you press F2, it will display this message. When you press F1, it will display this message, which is actually already displayed by default. But if you were to go into one of the other displays, you can get back to it by hitting F1. So we'll look at all those in a moment. But if we look at our labels here, and these two are very similar, you don't really have much options with this tiny little distribution here. You have your kernel, which we've already said was our ZM Linux file. In this case, again, it could be called pretty much whatever you want, but whatever it's called, you have to tell it in here. And also, you notice it says /boot because it's in the boot folder. You could rename that folder something else. But it's saying, okay, the computer will mount this ISO, or basically it's going to be a CD at that point. It's going to look at the CD, and it's going to say, okay, load the bootloader, which we'll get into all, how you add a bootloader to the image in future tutorials, hopefully. And then it's going to say, okay, the kernel is this file here. So if it was in the main directory, you wouldn't need the boot part of this. Or if you called the folder something else, you would go that route as well. Now again, we started talking about the Initrd, which is the initial RAM disk. Now when a Linux system starts booting, the bootloader is loaded, and then the bootloader will take the kernel, this file up here, and put that in RAM. And then it will take the initial RAM disk, which is this file which we were just looking at, and put that in RAM. And what this is it is a very basic, minuscule file system of Linux. And once that's loaded to RAM, it needs to be loaded to RAM so that the kernel can use files on it to mount the real file system and do some other stuff that the kernel can't do on its own. Well, I don't know. I've read that you can create the kernel in a way that it doesn't need that. I've read that. I've never actually seen that. I don't know if that's true. But 99% of the time, it's going to load, it's going to uncompress and load this image into RAM. And then it will basically start running that, and then later on in the process, it will mount the true file system, which will kind of override the initial RAM disk. So that's what the initial RAM disk is, and we're going to have a lot of fun playing around with that in future tutorials. But again, going back down here, we have file names, and this says F2 and F3. They don't have to be called that once again. This is a config file. You're pointing it towards, get out of that, this F2 file, this F3 file, this F4 file. And if we cat them out, we can cat out the first one is the boot message, which shows up by default. It was at the top of our config file there, which is our default little message here for TinyCore. And it says right here you can press enter to choose an option, or you can press F2. And if you were to press F2, in this case, it would display what's in the F2 file or the F3 file. So that's how when you boot a CD and it gives you different options, that's where all those options, the menus are displayed anyway. And then you can run those options, obviously. So let's get out. Don't want to spend too much time on one distribution. I just want to show you that they're all very similar but different at the same time, all depending on how the creator wants to organize stuff. So it's basically the same thing but organized differently. So we're going to quickly unmount that ISO, and now let's mount the mini ISO, which is the Debian netboot. Now remember when we went into the initial folder for the TinyCore, there was only one folder in the root directory, which is boot. Well, when we go into this ISO and list out the main directory, you notice there is a lot of stuff here. And one of the reasons for that is that its bootloader is, and its image, its initial RAM disk image, and its kernel is all just put into the main directory here. Once again, it's all depending on how the developer wants to organize stuff. But again, we do have our ISO Linux config file here. And if we were to less that out to display it, you can see it's actually shorter than the other one. Why is it shorter? Well, because Debian, the NetBoot CD, gives you a lot more options. So what they've done is broken it down into different config files. So you can see the first thing this config file does is it loads the menu config. It sets a default, but you notice that the labels aren't here, but it's because they're in another file. And it set the default prompt timeout to 0, which I believe if it's 0, that means it never times out. It waits forever until the user picks an option. So let's look at that menu config file. So we'll say less the menu.config. You can see this one's a bit bigger. And it has these menu options, which actually are setting up the height, shift, and width. So it's kind of changing where things are going to be displayed rather than just displaying a text message. We have a menu title in here, and then we start including other config files. You can see there's a lot of config files because you have a lot more options with this CD. And the only label in here is the help menu because the Debian CD actually has submenus with options in them too. So they've just broken them all down into different config files and they include them. So including them is basically like typing them here. They could technically all be in this one file, really long file, but they decided to break it up to keep it a little more organized. So I'm going to look at this one in particular, this AD text. If I less that out, you can see that we have two main options here. We have expert and auto. They have labels here, and they also have, just like before, we have our Linux kernel, which in this case is just called Linux, which we'll look at that in a second here. You notice there is no folder because everything is inside that root directory on the ISO, on the CD when you're booting it. Then we have our append option here, which within it has a few different options for the boot process. But the main one we're interested in most of these tutorials is, again, the Initrd, the initial RAM disk. And again, it's called, as I said, most commonly it's going to be labeled initrd.gz or just initrd. I think in some cases it might be initfs or ramfs or something like that. Technically it can be called whatever you want, but you have to make sure you put it into your config file properly. Let's exit out of that. Again, you can see those files in this main folder. And again, if I was to use the file command and say Linux, it says that it is a Linux boot sector. Well, it says the Linux file is a boot sector. It doesn't say that it is a Linux boot sector. And if I was to file our init RAM disk, our initial RAM disk, you can see here again, this one is a GZ compressed data file, but it was an initrd. It was the name of the file. So once we extract that out of there, then we can run file on it again. It will tell us what type of compression. I'm going to guess that it's probably an CPIO file archive, but I don't know for sure. The reason we saw that before, I believe, is because the original file had that extension. This one does not. But once we uncompress it, which we're going to do in a future tutorial, we can run file on it again and find out more about it. And there's actually other programs that we can actually scan through these files with. So again, very similar as far as the bootloader goes, but as far as where they put the files and name the files, very different. So don't let that confuse you. Basically, always look for this ISO Linux config file, and it will tell you where the kernel is and the initial RAM disk. So let's get out of that image. Let's unmount that. Let's mount the Mint ISO now. And we'll go into the ISO folder. And you can see, once again, this one's different. Not everything's in the root directory, which I think is kind of sloppy looking, but whatever. It does have a boot folder, but it's got other stuff. Again, also with the Debian one, some of these are like this mint4win.exe. These are files for, and this auto run, those are for Windows. So you put the CD into Windows, it will auto run, probably that mint for Windows. So yeah, if you were running a version of Windows that allowed the auto run. I think they somewhat removed that. Basically, that's an install process for Windows users. But again, we're interested in the ISO Linux folder. So we're going there, and we'll look at here. And again, this one has a lot less options than the netboot for Debian. Let's look again. Let's less ISO config. A lot of stuff going on in this config file. A lot of this is just making the splash screen, making the menu look pretty. We have its default is this menu option. Its timeout is set to this. We have our background is a JPEG, which was on the CD. We have our title, and then we have like color settings for different portions of the menus. And then we get into our stuff here, and here we can see our kernel for Linux Mint is inside Casper. Same is going to be for Ubuntu, and it's called VM LINUZ. That's our kernel, and that's a very common name for it. Sometimes it'll have more information, especially once you install it to your hard drive, on maybe what version of the kernel it is. We'll say like -3.3 or whatever kernel version it is. But again, it doesn't matter what you call it as long as in your config file you point to it. Again, you have a lot more append options here because you have lots of different options in here. And again, of course, our initial RAM disk is also in that Casper file, and it's called inish ramdisk.lz in this case. So let's quit out of that. Go back a directory. Go into our Casper folder here, list, and here is our kernel. Here is our RAM disk, our initial RAM disk. Let's file that out, and you can see it's saying that it's a GZ compression. I don't know if it's a different type of GZ compression since it's labeled LZ. But again, it all depends on what's compiled into the kernel that you're allowed to. And again, we'll look more into that. I'm just showing you in this tutorial how different things are set up, showing you where the kernels are and where their RAM disks are. But you notice if we list this out and we bring it up, you can see that there's a file system.squashfs here, which is another type of file system. And it's 847 megabytes. That is your actual root file system once your full operating system is loaded. And on a CD, in this case, what happens is it's going to load your bootloader, which is going to load your kernel to RAM and this initial RAM disk. And then from there, it's going to mount this file system, but not uncompress it. When you're running a live CD, it's pretty much uncompressing on the fly in most cases. If you were to completely uncompress this, it's going to be probably about 3 times its size. So it's going to be probably over 2 gigs once it's installed to your hard drive. Technically, you could put the full operating system inside your initial RAM disk and load it to RAM. And there are operating systems. Well, the last 2 operating systems did that. Our Tiny Core and our Debian NetBoot CD. But those are both very small images. You could technically reconfigure Ubuntu or Linux Mint to load the full operating system to RAM. Then you can take the CD out, you can unplug the flash drive. It'll probably be pretty fast because everything's already uncompressed in RAM. But you got to remember, in this case, it's going to be taking up about 2 gigs. So if you have a 4 gigs of RAM, you only have 2 gigs to work with, which is still plenty if you're just working with a live CD, but you could run out of space very fast. Also, to uncompress that and copy it all to RAM will take a couple of minutes, so your boot time will be a couple of minutes. But talking about that, let's go we'll unmount that, and we will mount our Slitaz ISO. And we will go into our boot folder, list in there, and you'll see as I was saying earlier, here's our kernel and its version. This is also a kernel image here. If I file that out, BZ image, and if I list them out, they're both the same size. It almost looks like they have the same kernel on there twice, maybe. I haven't looked into that. I noticed that right before I started recording this tutorial. And if we were to go into our ISO Linux folder, we can see we got a bunch of config files, but we'll do our main iso.config file here. It also has some formatting for the menus, and we get down here and we start looking at some of these. And if we look here, you can see our kernel is the BZ image file. So I'm not sure why they have that other image file on there. But you notice their initial RAM disk is in their boot folder, but it says root file system 4.gz, and then it says comma, and it does 3 and 2 and 1. And so they actually have 4 different initial RAM disks. Now, why is this? Now, I've done tutorials on SLTAS in the past, and it was an older version of SLTAS. This is SLTAS 4.0, and I did tutorials on version 3. And with version 3, they had different distributions of it, different I think they call them cooks when it comes to SLTAS. They had a image that was just under 10 megabytes, which was just a shell. One that was 15 that did just X. Then they had one that was probably about 20 that did X in a browser, and then around 30 megabytes, which was their full operating system. Well, what they did with version 4.0 is that you can basically tell it what file systems to load over top of each other. So this is loading the full desktop with all its files. The next option is Gtk Only. So it's basically the GUI but without the desktop interface, I believe. So you notice that one is missing here. So basically, and then we'll go down, we'll say just X. So it has X but really no other GUI applications installed, which is just 4 and 3. And then we have their base, which is just 4. So basically, instead of having all these different images, ISO images, they put them all on one. So you still only have a 35 megabyte CD for the full operating system. But when you get to your boot menu, you can choose whether you want to load to RAM. And again, this operating system is so small, it does load to RAM. At least that's the default setting. And we'll look more into that in a second. If we want just the shell with no GUI stuff, it only loads file system, which is our initial RAM disk, 4. Well, if you want just X, well, it's going to load 4, and then once 4 is uncompressed, it's going to uncompress 3. Well, if you want X with some GTK stuff, well, it's going to uncompress all 3 of these. It will do 4 and then 3, basically putting them all in RAM on top of each other, mounting them all up there. And there are options. They have some other ones where they boot from. I guess not on the CD. They do also have low RAM versions of SLTAS that don't uncompress to RAM at all. It will actually run it off like other live CDs. So anyway, I thought that was really neat, the way that SLTAS decided to do that instead of having all these different CDs. It's so small. There's going to be very rare cases where you have some sort of media that will hold 8 megabytes but not 35. So why not put them all on the same disk? It doesn't matter. You can choose what loads to RAM, and then you take the disk out. So if you want that really lightweight 10 megabyte shell only, you choose that, and the disk comes out. It's all in RAM, and it runs. So I thought that was really neat. So let me quit out of here. The rest is pretty much the same. By the way, there's that splash JPEG, so when this distribution boots up, it will display that image. Yeah, you got other options there, your help menus and stuff like that. It has a few different language options, but all from those config files, which are plain text. And here are all those files. So if I list these out real quick, you can see that if we were to just do the base OS, it's actually, I said it was about 10. That would be the full ISO if they had that with all the bootloaders and everything. But the actual file system is just under 5 megabytes. So you would have a full shell just under 5 megabytes. If you wanted just X, you would have another. It would do the 4, and then on top of that add 8. And then if you wanted GTK, it was another 6 megabytes on top of that. And then if you want the full desktop web browser and a bunch of other tools, it's another 13 megabytes on top of that. So genius the way they did that. Kudos to them. And that's kind of, this tutorial was kind of long, but I just wanted to show you all the different ways that you can do the same thing, basically, and how different developers decide to organize things differently and what you can do, and really point out that what the kernel is and what the initial RAM disk is. Because you would see those probably a lot if you've ever messed with your bootloader configure, and maybe you didn't know exactly what is this Initrd. Well, it's the initial RAM disk, and it's basically a very minuscule, simple Linux file system that's loaded to RAM that allows the rest of the operating system to load, because the kernel itself needs tools which are going to be in that file system to load. And we're going to be looking at that stuff a lot more in the future. So I know this tutorial, I don't know how long I've been going for, but it's probably been kind of long. I hope you enjoyed it. Be sure to subscribe. Be sure to check out the full playlist. Again, a new video every Monday for a while now. So the playlist, there should be an annotation on the screen. If you're watching the playlist and you get to a video that you can't access, it's because it hasn't been published yet. Next week it will be published. Got to say that, or people will ask why they can't access it. And we're going to be doing a lot of uncompressing these files, manipulating them, recompressing them, different types of installs. But I wanted to show you what these are, and I love this sort of stuff. I love small distributions. I love tweaking around with them, and I hope that you enjoy it as well. If you do, if you like these type of tutorials, we're going to get more in depth in future tutorials. Be sure to like this video so that I know you guys are enjoying it. Comments are great below. Questions, probably not the best place to put them in the comments. Check out my website for a link to the IRC channel, which is a good place to ask questions. I am far from being a professional on this sort of stuff, but I know a little bit, and I'll be glad to help you in any way I can. And be sure to subscribe and check back next week for next week's video. Thank you for watching. Please visit filmsbykris.com. That's Chris with a K. There should be a link in the description. And I hope that you have a great day.